Alright, video number 2 on the introduction to the law of sines and the law of cosines continued. So now we're going to talk about the law of cosines. So the law of sines is what we just introduced, which we said that you have to have a side and its opposite angle in order to be able to use the law of sines. We're going to put it into practice in a second. So the law of cosines, when are we going to use the law of cosines? There's two situations when you can use the law of cosines. To be used when you know two sides and the included angle, so two sides and the included angle, or if you know three sides. So if you know two sides and the included angle, or if you know three sides, you can use the law of cosines. Well, there are three formulas for the law of cosines. These formulas have to be memorized. It shouldn't take you too long to memorize them, all of possibly 10 minutes if you just write them out 20 times each. So, three formulas for the law of cosines. First one, and you might be able to notice a pattern in these formulas. C squared is equal to A squared plus B squared minus 2AB cosine of angle C. This is the big C. All the other letters are the sides. So all the other letters are small because you're talking about the side lengths, and that last letter is the angle. Whenever you take the cosine or a sine of something, you're taking it of an angle. But since this is a law of cosines, you're only going to see cosine in the law of cosines, which makes sense. So C squared is equal to A squared plus B squared minus 2 times the first two terms that were in here, AB, 2 times AB, times the cosine of whatever it's equal to, C squared, right? So it was equal to C squared, so you're going to take the cosine of C, angle C. Cool. Second one. A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A, big A. And the last one, you could have guessed it, is B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. Again, B squared is equal to A squared plus C squared minus 2 times A times C times cosine of B. So, whenever we have the law of cosines, we know that we're going to use it whenever we have two sides and an included angle. So if you don't know what that means, an included angle, let's say we have the triangle ABC. ABC. So we know that opposite of B is little b, opposite of angle C has to be little c, and opposite of big A has to be little a. Well, let's just say that I gave you these three values. Angle A is 32 degrees, side C is 10, and side B is 20. If I gave you these three pieces of information, then that means, let's see what we got. This is 10, this is 20, and this is 32 degrees. Well, this angle is the angle in between those two sides. This side and this side, that angle is called the included angle. It's like a slice of cheese in a sandwich. If it's in between the two pieces of bread and not outside the bread, it's included in the sandwich. Cool? Good. Making me hungry. Alright, so it's included in between the two sides. Awesome. That's what we're talking about. Whenever we have two sides and an included angle, we can use the law of cosines to figure out everything else. So, warning. So since we are working in degrees, you need to convert your calculator back to degree mode. So anytime that we're working in degrees now with the law of cosine and the law of sines, because you're going to see degrees. You need to convert your triangle, or you need to convert your calculator back into the degree mode. Awesome. So now let's get to work some sample problems. Let's work some sample problems on what this might look like. So sample problem number 1. I highly recommend that you work this on a separate sheet of paper because you're not going to have enough room. So just get a separate sheet of paper and work it on a separate sheet of paper. That's exactly what I did. So the question reads, in triangle ABC, the measure, so M angle A means the measure of angle A is equal to 32 degrees, A is 42, and B is 30. So now what you have to do is you have to be able to, the directions tell you that you have to be able to solve for all the missing information. So first thing it says, draw a triangle which includes the given information. Number 2 is decide if you will be using the law of sines or cosines. And the third thing is find all the missing information. So let's go ahead and do that. Let's go ahead and draw our triangle. So in triangle ABC, let's just go ahead and draw a triangle. A, B, C. Okay. The measurement of angle A, we know this is, so we know that the opposite of big A has to be side A. The opposite of angle C has to be side C, and the opposite of angle B has to be little b. So let's see what we have. The measurement of angle A is 32 degrees. So let's go ahead and plug that in. 32 degrees. A is 42. So we can erase the little a. So that's 42. B is 30. Little b is 30. So what are we missing? Well, I go ahead and circle all of that. I circle angle C, angle B, and side C, side little c. Well, first you have to ask yourself, do I have a side and an angle that corresponds to that side? Yes, I have side A, little a. Well, let's just call it side A. We have side A and we have angle A. So if we have side A and angle A, what did we say that we can do? If we have a side and its corresponding angle, we said that we're going to use the law of sines. So law of sines, because whenever we use the law of sines, if we have another side, we can use it to find that side's corresponding angle. So let's say we had the sine of 32 degrees, which we got right here, the sine of this angle, 32 degrees, the sine of angle A, divided by side A, divided by 42, is equal to sine of B divided by B, which is 30. Side B, which is 30. So if you're confused on how I got this, the only thing that I did is I said that the sine of 32 was just the sine of angle A divided by side A, which is equal to the sine of angle B divided by side B. I can only have one thing that I don't know in the law of sines. Why? Because if you know 3 things, you'll be able to solve for the 4th. So let's do that. How are we going to solve for B? Well, we have to multiply both sides by 30. When you do that, you're going to get 30 times the sine of 32 degrees divided by 42 is going to equal to the sine of B. Well, how do I solve for B? Well, to undo the sine function, how do you undo the sine function? You take its inverse. So you say the inverse sine of the sine function, that cancels out. If you took the inverse of on the left side, you have to also take the inverse sine of the other side. So B is going to equal to the inverse sine of 30 times the sine of 32 degrees divided by 42. If you do that on your calculator, you plug it in, you will get that the measure of angle B is going to equal 22.417 degrees is equal to the measure of angle B. I did this on a separate sheet of paper. As you can see, it's very beautiful, pretty hot. And yeah, see, I ran out of room on my box, my big box, ran out of room. So, separate sheet of paper is what I expect. So, 22.417 degrees was a measure of angle B, which we just found. Now what I want you to do is, we're going to think about this. So if we know angle B is 22.417, so we just found that that's 22, this angle right here is 22.417 degrees. Can I find angle C if I know angle A and angle B? If I know that angle A is 32 degrees and angle B is 22.417 degrees, is there a way for me to find that last angle? Yes. So, how can I do that? Well, I know that the measure of angle C has to equal 180 degrees. I'm going to put this in a different color so you can see it better. The measure of angle C has to equal 180 degrees minus the sum of the other two angles, 32 degrees plus 22.417 degrees. Whenever you subtract those, because you know that the sum of the angles in a triangle has to equal 180 degrees, you're going to get, for that last value, oh, mom called, gotta, hold on, call it back in a minute. So, 180 minus those degrees is going to give you a value of 64, no wait, hold on, 125.583 degrees for the measure of angle C. 125.583 for the measure of angle C. What else do we have? Do we have anything left? Yes, we do. We have one more thing that we need to solve for. I'm going to go ahead and erase this because we've already gotten the measurement of angle B. Okay, so we've already gotten the measurement of angle B. There we go. So one more thing we need to solve for. We just found that the C value's angle. We just have to solve for the other side. We can't use a squared plus b squared is equal to c squared because that's Pythagorean theorem. It only works whenever we have a right triangle, which we do not have. So how are we going to solve that? Well, I have a side and its corresponding angle, and I have, we just found that C, okay, and I also have that angle C that we just found. So I like to use the law of sine sometimes because it's pretty easy. It's a lot easier to use than sometimes the law of cosines can get a little tricky whenever you're plugging it into your calculator. So if I know angle C is 125.583 degrees, can I find the side C? Yes, I can, because now I have its corresponding angle, and I also have my sine of B divided, so my sine of 22.417 degrees, which is the sine of B, the sine of angle B divided by the side B, has to equal the sine of angle C, which is 125.583 degrees, divided by the corresponding side of ABC. Can I solve for C? Yes, I can. How am I going to do that? Well, all I have to do is multiply both sides by C. So I'm going to have C times the sine of 22.417 divided by 30 is equal to sine of 125.583 degrees What do I have to do? Multiply by 30 and divide by the sine of 22.